Okay, I'm having so many issues with this video. I have made this video twice already. Each time the video has been like 8-9 minutes long, and it's taking forever to do it. And then at the end, the video got messed up. And now I realize I uploaded the first two videos for this series in the wrong account. So this is just super random. If you're confused, I'm gonna upload the first two videos that kind of explains all the, like, this is the third video for this unit, except the first two I uploaded the wrong count. I'll upload them onto this one later, and everything is being so hard. So I decided, instead of writing this all out for a third time, I'm just going to kind of point to stuff and show you why I did stuff, and this video might be a little shorter for that reason. I'm not gonna go through this question for the third time and write everything out again. So basically, in this video, I'm talking through story problems of what we did in the last two videos that you guys will see later once I upload them, because they're on the wrong account. But basically, we talked in the last two videos about differential equations, what that means, and how to solve for them by separation of variables. And then we talked about inversely proportional, directly proportional, and jointly proportional. Now, you're going to be given story problems such as these that are going to test your knowledge on that. So the question that I have, which I'm going to put in the description, says, the rate of change in the amount of liquid running out of a funnel is inversely proportional to the amount present in the funnel. If 4 cubic inches of liquid begin to drain out of a funnel and half is drained after 30 seconds, find the time needed for the funnel to be completely empty. So what I did at first was I defined my variables. I said L is going to be the amount of liquid in the funnel, and T is going to be the time that is taking for the liquid to flow out of the tunnel. And then I decided to write over here the 3 points that I know. I know, if I'm writing points in TL form, that at the beginning, at time equals 0, there's 4 cubic inches. So you have a point of 0, 4. And these points, by the way, are in the original equation, not the differential equation, and I'll tell you how to get that in a second. But then we know after 30 seconds, it's been halved, so at 30 seconds, there's going to be 2. And then, last but not least, we have, we want to know what time it's going to be 0. So the question says that it is the directly proportional to the amount present in the funnel. So directly proportional means 1 over something, and we know it's going to be k over something, and because it's directly proportional to the amount present, the answer is dl dt is k over L. I did work here by cross-multiplying, but then I brought the k over, and I had this big speech about how k and 1 over k are the same thing because there's no specific values assigned yet. You're just solving for an equation, so some constant, and then the inverse of that same some constant. That's just some other constant. Either way, it doesn't matter. So you can divide that over and get k L dl equals dt, and then I took the integral of both of those and got k over 2 L squared equals t plus c. There's supposed to be a c over here, but I just put the c only on this side. And when you solve for L, you get L equals the square root of 2t over k plus c. I then started plugging in points. I said that because there's a point of 0, 4, then you plug in 0 for t, and because you have 2 times 0 over k, that's just going to end up crossing out and being 0. So you're going to get 4 equals square root of c, and c equals 16. Then you're going to rewrite the equation you had at the beginning, but plug in your c value that you got, and you get L equals 2t over k plus 16. Then plug in your other point, and you get 2 equals 2 times 30, which is 60, over k plus 16. Solve for k, and you get k equals -5. Bring that back over. Here's your final equation. K equals the square root of 2t over -5 plus 16. And now I want to know when the funnel is completely empty, and that's when L equals 0. So you plug in 0 for L and solve for t, and doing algebra, you get 40 seconds. That was a lot quicker than my other videos, and I hope that made sense to you. But yeah, I really hope this video works.